Okay, so this is the last video of the semester, and this is going to be a much quicker one. So this one is just going to go, we're going to talk about things that we can do with radioactive isotopes. There's actually many things that we can do with radioactive isotopes. I'm going to go through the notes. You guys can write down these answers on page 15, and then at the top on page 16. So we've got lots of good things we can do. We can generate power. We've got nuclear power plants. We have a lot of electricity from nuclear power plants. We have nuclear medicine. We can scan your bones. We can look at your thyroid. We can detect cancers. We can treat cancers. But we know that it can be extremely dangerous as well. We can produce nuclear bombs, which no one really likes. And there's also the threat of meltdown for nuclear power. So there's some of the medical benefits. We can also do radiological dating. This is what you looked at when you did earth science. So if you look at uranium-238, it decays after about 1 billion years to lead. Lead is stable. It stops emitting radioactive, any kind of energy or subatomic particles. It's all done. So if we look at, let's say, a rock, we can figure out how much uranium-238 is still present versus how much of the lead is present. So that way we can determine how old a substance is. We can also, it's in smoke detectors. Your americinium-241 is a radioisotope used in smoke detectors. Food, we use it to irradiate food. I haven't seen this around very often anymore, but once in a great while I would find hamburger meat that would have a label on it that said irradiated. And that just means that they use this isotope it produces gamma rays and they penetrate everything. So it would kill any microorganisms that could be pathogens in your hamburger. We can look at radioactive tracers to study the processes in plants like P32, right? P32, phosphorus is a pretty big component of your DNA, right? That's the backbone. And we can watch DNA replicate. We can watch DNA be converted into RNA. And of course, what that means that we can watch all sorts of other processes too. Iodine-131 is used to treat thyroid disorders, and we use technetium-99 to treat cancers and do bone scans. So again, it's important that we have a half-life that allows us to, gives us the time to detect, but also we want to make sure it's pretty short because we don't want to be radioactive, like really radioactive for a really long time. So here's some more information about cobalt-60. And technetium-99 and iodine-131. And then irradiating meat looks like this. If I put my sample of meat in the center, eventually, right, it goes through this conveyor belt. Can't have people in there because it's producing gamma rays. But then the radioactive isotope's in here, and the meat goes around it. So as it travels around the radioactive isotope, it gets irradiated and kills all of any parasites or microorganisms that could be pathogens. So detecting this radioactivity, right? If we have a radioactive isotope, we have to be able to detect it. One way to do that is with a Geiger counter. This is what a Geiger counter looks like, and it beeps. So the more radioactivity that's present, the more beeps that you get per second, or counts per second, or counts per minute. Depends on the scale of your Geiger counter. Your film badge. This is what I used to wear when I was in the lab. So they would give me a film badge. Radioactivity is energy, right? So radiation is energy. If I was exposed to that, it would expose the film, and my level of exposure on the film tells whoever's monitoring this how much radiation I've been exposed to. So if it's not very exposed when they go to analyze it, that's good. Everything's fine. And I've never been overly exposed, so that's good. Versus if it was really exposed, the film was very exposed, then that would be bad. All right, guys, those are your uses of radioactivity. That is all of the videos for the semester.